Hi, welcome back to the channel. In this lesson, we'll look at equation of a circle. I'll start by explaining the equation of a circle when it is at the origin of the axis and also when it is out of the origin of the axis. After which, we'll use a question to help us understand it better. That said, let's get into class. Hi, welcome back. Here's a circle on the Cartesian coordinate. Here's my y-axis and here's my x-axis. Obviously, on this circle, here's the radius of the circle. The radius of the circle is the line that moves from the center of the circle to any point on the circumference on the circle. Here's a radius, here's another radius, and all the radius of the circle are definitely equal. Now, another unique characteristics we will definitely encounter is the diameter of a circle, which is the same thing as 2 times the radius of the circle. Now, to define this circle at the center or at the origin here, my x is 0 and my y also is 0. The best way and easiest way to define this circle by an equation is to use the radius. Now, at this point here, let's tag this point x and y. This point x, that is, at this point here on the x-axis, we're saying that from the origin 0 here to this point here, we have x. And also, we're saying that from the origin to this point here on the y-axis, we'll have y. Now, to define this radius, which we'll use to define this circle, we're saying that r squared is equals to x squared plus y squared. Now, this is the equation of the circle when it is at the origin. That is, when my x here is from 0 and my y definitely is from 0. Now, let's see it when it's out of the origin. Now, once again, this is my y-axis and here is my x-axis. And this is a typical example of a circle that is out of the origin. Now, let's note that at the tip here or at the circumference here, this is my point x and point y. But at the same time, this circle has a center, which obviously we don't know. Let's tag this point here A and point B. Now, I'd like to trace both points to the x-axis and also then I'll trace to the y-axis. At the x-axis, you know that point A from here to here, this is point A, and same time you have x here. This is for the x-axis. For the x-axis, this is my x. Now, obviously, between here to here, you know that this is a difference, and that is my, let's tag that as x. If you look at this already, you see that this is beginning to form another right-angled triangle this way and this way. And for my y-axis, this point here is y. Obviously, that point y will represent from 0 to point y here, which will be y. And from here, this point here, down here, that will definitely be my what? My b. My b. So from here to here, let's tag that as my big Y. And that will be equals to, from here to here, that will be equals to my Y minus my B. And this X here is also same thing as my X minus my A. Because if from here to this point here is X, and from here to this point here is A, definitely the difference between the 2 points will be my X minus A. And of course, this is my R. So to define this circle like we did the initial time, we'll be saying that my R squared from Pythagoras theorem is the same thing as my big Y squared plus my big X squared. Now, and we know that from this diagram that my Y here is the same thing as small y minus b, and my x here, as in the big X, is the same thing as small x minus a. So I can substitute in this to have r squared now to be equals to y minus b all squared plus x minus a all squared. Now, this is actually the equation for circle. Now, the good thing you should just know about this equation is that when it's at the origin, my a and b they are equals to 0. So the equation will reduce to r squared to be equals to y squared plus x squared. This is when they are at what? At the origin. This is when they are at, let me use an at sign, at the origin. Now, my example says that the line segment AB is the diameter of a circle. Let's draw the circle. Here's a circle. Then I would like to draw the Cartesian coordinates to suit this diagram. And where A and B are 4 and 7, I'll pick this A and B 4 and 7, that's in the positive axis. That's 4 and 7, both of them are positive. And B is minus 8 and 3. Okay, minus 8, that's negative in the x-axis and positive in the y-axis, and 3. So this is the line joining those 2 points together, so that if I trace this downwards here, this is my minus 8. Here, tracing this downwards here, this is my assumed 4. And on the y-axis, here is my 3. And on the y-axis here is my 4. Now it passes through the center, definitely, because it's a diameter. Then if it's a diameter, we can always calculate the radius from that diameter. So with this, I can find the diameter. In case you missed our lesson where we treated distance between 2 points, please don't hesitate to check the description below. So that my d now, which is the diameter, will come from 4 square root of 4 minus 8. This is all squared plus 7 minus 3 all squared. So that my d now will come from the square root of 4 minus 8, that's 12 all squared plus 4 all squared, which will come from d now will be the square root of 12 times 12, that's 144 plus 16. That's d. That will be the root of 144 plus 16. That's 160. So that d obviously is 4 root 10. Now, if d is equal to 4 root 10, we know that r is the same thing as d over 2, which is equal to 2 root 10. So that r is equal to 2 root 10. Now, we've gotten r, and remember our formula tells us that r squared will be equals to x minus a all squared plus b, or y, sorry, minus b all squared. Now we've gotten r squared. The next thing is to obtain the center, the actual center of this circle. Now, since the diameter is a straight line, we can always get the center of this circle also from the diameter. Now, to get the center, the midpoint of a straight line is just picking the sides of the straight line, adding them together and dividing it by 2. Now, that straight line ranges between A is at 4 and 7, and B is at minus 8 and 3. So that the midpoint, or the center, will come from 4 minus 8 over 2. That will be the x component. The y component will come from y, that's 7, plus 3 over 2. So that the midpoint will be at 4 minus 8, that's minus 4 over 2, and 10 over 2, which is the same thing as minus 2 and 5. Now, with this, I can construct the equation of my circle. Remember, my equation says r squared is equals to x minus a all squared plus y minus b all squared. So that my R now, my R is 2 root 10 all squared will be equals to x minus a. My a in this case is 2, is minus 2. Minus 2 all squared plus y minus 5 all squared. So that will be 4 root 10. That's 4 into 10. The same thing as x plus 2 all squared plus y minus 5 all squared. You can decide to expand further so that this is 40 equals x squared plus 4x plus 4 plus y squared plus, or that will be minus 10, not positive any longer. Just that will be minus 10y plus 25. Now, if I have to rearrange that, my 40 will be the same thing as x squared plus y squared plus 4x minus 10y plus 29. So that, let's collect like terms, so that 29 goes to the other side, becomes 40 minus 29. That's 11 is equals to x squared plus y squared plus 4x minus 10y. Now this is the equation of that circle. With this, I hope you understand how to work with finding equation of a circle. We'll take further questions in our next lesson to help us understand it better. Thank you and see you in our next class.